Hello everyone. In this lecture, I am going to explain how to design a decoder using basic logical gates. So before going to discuss this decoder, which is similar to demultiplexer, in the previous lecture we have been discussed regarding how to design a demultiplexer, and it is quite opposite to encoder. So basically, this decoder is in a combinational circuits. So decoder is a combinational circuit that has n input lines and up to 4 n output lines. That is, here the principle is n is 2 to the power n. Say for example, n is equal to 2 means, so 2 inputs and 4 outputs. So this is the principles of decoder. So one of these outputs will be high based on the combinations of inputs present. Yes. So see, here are 2 inputs, so 4 possible combinations, so 2 power n possible combinations are there. So the combinations are 0, 0, 0, 1, 1, 0, 1, 1. For these combinations, each and every combinations, any one of the outputs should be 1. That is 4 outputs. Those outputs are y3, y2, y1, y0. So for the first combination, any one of the output is 1. Second combination, any one of the output is 1. And third combination, any one of the output is 1. And fourth combination is any one of the output is 1. It means the decoder detects a particular code. The outputs of the decoder are nothing but the minterms of n input variables lines when it is enabled. Yes. So these outputs are going to be written in a SOV format. That is, these are all the minterms, input minterms. So the output should be written in the SOV format. Okay. Right. So let me discuss how to design a 2 to 4 decoder. So here 2 is the input and 4 is the output. So this is input and this is output. So we can take any variable, that is any alphabets to represent inputs and outputs. Okay. And next, so 2 to 4 decoder has 2 inputs. So here in this design I am going to consider A as a input variables and Y as a output variables. So have a look at the block diagram of decoder. So in this, see, as already mentioned, A1 and A0 are inputs, and Y3, Y2, Y1, Y0 are output, and E as an enable input. Whenever this enable input is high, that time only this 2 to 4 decoder is going to be work. If the enable input is 0, then it will not work. Okay. So one of these 4 outputs will be 1 for each combinations of inputs when enable is 1. Okay, so one of these output will be 1 when each combination is present as well as the enable is equal to 1. Okay, so have a look at the truth table of this 2 to 4 decoder. So first one is the enable input, first column, it is E, and the input is A1 and A0, and outputs Y3, Y2, Y1, Y0. So for the first condition, enable is equal to 0, at that time whatever may be the inputs, maybe it is a 0 or 1, so for that here I have represented as a don't care. So here X indicates don't care. So at this time the outputs are equal to 0, there is no output, because enable is 0, then there is no output. When enable is 1, now only we are going to apply the combinations of inputs. So first I am going to apply the combination 0, 0, then I am going to apply the combination 0, 1. Then 1, 0, 1, 1. So for each combinations of inputs, only one output. Okay, the output should be only 1. So see, for the first combination, it is 0, 0. The output is 1 at the LSB side. That is, Y0 is the lowest position. This is the LSB position, and this is the MSB position. So always 0, 0 is the lowest value. So for this lowest value, the output is in the LSB side. When the next combination is 0, 1, the next highest output is equal to 1. When 1, 0, the third output is equal to 1. And 1, 1, the MSB output is equal to 1. Okay, so in this way only we are going to design or construct the truth table. And as per the procedure of a combinational circuit design, after constructing the block diagram and the truth table, the next step is we need to write the expressions. So we are going to write the expression for the output variables Y3, Y2, Y1, Y0. So have a look at this output Y0. It is having 1 at only one place, so that place is here. So at that time, look at the corresponding input. What is the corresponding input? The inputs are A1 is equal to 0 and A0 is equal to 0 and E is equal to 1. So how to write this expression? That is, Y0 is equal to, E value is equal to 1, so E will be there. And A1, A0. A1 is 0 and A0 is 0. So in min term, A1 is 0 means it is A1 bar and A0 is 0 means it is A0 bar. Okay. Similarly, for Y1 it is having 1 at only one place. So in that place, the corresponding inputs are A1 is equal to 0 and A0 is equal to 1 and E is equal to 1. Okay. So Y1 is equal to E into A1 bar and A0. Similarly, Y2, the corresponding combinations of inputs, A1 is equal to 1, that is E is equal to 1, A1 is equal to 1 and A0 is equal to 0. Similarly, Y3, the corresponding inputs are, all the three inputs are including enable, it is 1. So E, A1, A0. So this is what the expression of all the four outputs. Okay. So next step is we are going to construct the logical diagram from the expression. So I think here A1 and A0 are having bar in some particular places. So we are in need of a NOT gate for this A1 and A0. As well as for Y0 we are in need of one AND gate because this is a product term. Okay, E into A1 bar into A0 bar, this is one product term. Similarly, Y1, one AND gate is needed, and Y2, one AND gate is needed, and Y3, one AND gate is needed. So totally here the required gates are 2 NOT gate and 4 AND gates. Have a look at this expressions. Just now we have derived Y3, Y2, and Y1, Y0, and the logical diagram. See, A1 and A0 are given some NOT gates. So here this is a A1 bar and this is A0 bar. So what is the first here they have taken Y3. So see, Y3 expression is E into A1 A0. So here it is E. So we have taken the E line and the A1. So here it is A1 line and this is A0 line. So A1, A0 and this is E. Okay. Similarly Y2, this is E into A1 into A0 bar. So here it is E and A1. So from here it is coming A1 and this is A0 bar. Okay, it is taken from this line. So this is A0 bar. Similarly Y1 and Y0 from the corresponding expressions we can be able to draw the logical diagram. So this is what the design of 224 decoder. So first step is understand the concept and draw the block diagram. Then the second step is construction of a truth table, and the third step is finding the expressions using K-map, and the last one is logical diagram. Okay. Right. So the next thing is implementations of a higher order decoders. Yes, like in multiplexer and demultiplexer we have discussed that we implemented higher order devices using lower order devices, and same concept here also we are going to use. So here we are going to discuss two things, 3 to 8 decoder and 4 to 16 decoder. So we are going to design these two decoders using the lower order decoders, that is a 2 to 4 decoder we are going to use. Okay, we'll see one by one. The first one is 3 to 8 decoder. So 3 to 8 decoder is our design. We are going to design. So 3 as a input, 8 as a output. So finally, after drawing that 2 to 4 decoders, our inputs and outputs are 3 input and 8 outputs. Have a look at the introduction part. So we know that 2 to 4 decoder, it has 2 inputs A1 and A0 and 4 outputs Y3 to Y0. Yes. So, but here we are going to design a 3 to 8. So for 3 to 8, 3 inputs are needed, A2, A1, A0, and 8 outputs are needed. It is from Y7 to Y0. Yes. Okay. So now we need to find how many number of this 2 to 4 decoder is needed. Okay. So there will be a formula will be there. That formula is M2 by M1. That is, here M1 is number of output for the lowest device. That is the lowest order devices. It is a 2 to 4 decoder, and this is a 3 to 8 decoder. So M1 is the lowest order output, and M2 is the highest order output. So it is nothing but 854, which is equal to 2. So we are in need of a 2 to 4 decoder. So have a look at this, where M1 is the number of outputs of lower order and M2 is the higher order. So as per the formula, M1 is equal to 4 and M2 is equal to 8. Then as per the formula, 8 by 4, which is equal to 2. Okay, so we are in need of 2 to 4 decoder. So have a look at this. So first I have drawn here one block which consists of 2 to 4 decoder. That is, see, 4 outputs here, and another one 2 to 4 decoder. Okay, so here also 4 output is there. So here the outputs are from Y0 to Y3, and here it is Y4 to Y7. Right. So for these 2 to 4 decoder, I am going to give two inputs are A1 and A0. Okay, starting from a lowest order, A0 and A1 are going to act as two inputs for this 2 to 4 decoder. And one more inputs we need to use, that input is A2. But where we are going to apply this input, because the decoder is having only 2 inputs, so those 2 inputs already we have been used. Okay, remaining one more place is there, that place is enable. Okay, so in that enable place, I'm going to use this A2 as a one normal input for one device, and for the another device I'm going to use as a inverted one. Okay, which means, see, if I'm going to construct the truth table of this, that is inputs are 3 inputs. This is A2, A1, A0, and outputs are from Y7 to Y6, Y5, Y4, Y3, Y2, Y1, Y0. Okay, so when I'm going to give 000, so it is going to produce the output is here Y0 place, which means, see, when I'm going to substitute here 0, 0, 0, so 0 goes to this enable now. So now this won't work because enable value is 0. So this enable will comes here 1. So see, now enable value is 1. So now this device will work, and this devices will work. But according to this 0, 0 input conditions, this is the lowest combination. So here the output will comes in the lowest position. So here the lowest position is Y0. So for 000 condition, output Y0 is equal to 1. Okay. Similarly, let me take 0, 1, 1. So 0, 1, 1. This is a 0, 1, 2. This is third one. So third one means Y3 output will be high. So see, 0, 1, 1. Y3 is 1. So let's check 0, 1, 1. So again 0 in the A2 place. So this won't work. So this place is 1 again. So now this will work. But here now the input is 1, 1. According to the 2 to 4 decoder design, this is 1, 1 means it will select the Y3. Okay. Similarly, I'm going to check 1, 1, 0. So 1, 1, 0. This is it is going to select Y6. That is Y6 output is 1. So have a look at this. 1, 1, 0. 1, 1, 0. Okay, so 1, 1, 0. So 1 means now this enable value is high, so now this will work and it won't work because here inverter is there, so this output is now 0. So this device it won't work now. Okay, so now the input is 1, 0. So 1, 0 means it will select the third output here. So Y6 value is equal to 1. So in this way only we are going to check how it is working. That is the 3 to 8 decoder using 2 to 4 decoder. Okay. Right. So that's all about this lecture. So in the next lecture we will discuss regarding the one more higher order decoder using lower order decoder. Thank you all.